Given the vector r of t is equal to the inverse tangent of t, 2e to the 2t, 8t e to the t, we're going to find the unit tangent vector t of t for the value t equals 0. Well, remember t of t, the unit tangent vector, is given by r prime of t divided by the magnitude of r prime of t, and so we need to take a derivative. R prime of t is equal to the derivative of the inverse tangent of t is 1 over 1 plus t squared. 2e to the 2t has a derivative of 4e to the 2t. And 8te to the t has a derivative of 8e to the t 1 plus t. That's the quantity of 1 plus t, of course. And we use the product rule. Now, folks, it is our saving grace at this point that we're asked to find t of 0, essentially. Because if we were asked to find t of t, then we need to find the magnitude of this vector. And while we can do it, it would just be really nasty. Instead, what we're going to do is we're going to find r prime of 0 and find its magnitude. If t is equal to 0, then 1 over 1 plus t squared is 1. 4e to the 2t is 4. And 8e to the t times the quantity of 1 plus t, if t is 0, is equal to 8. We then will be able to find the magnitude of r prime of 0, and it is the square root of 1 plus 16 plus 64, square root of 81. It's 9. Therefore, t of 0, right, uppercase T vector, unit tangent vector, of 0 is equal to 1/9 times 148. Now, folks, it's bad form to write it like 148 whole thing over 9. Please don't do that. There's no such thing as vector division. There is scalar multiplication for vectors, so we can multiply by 1/9. Our answer here, though, is going to be t of 0 is equal to 1/9, 4/9, and 8/9. And you can verify that this is a unit vector by finding its magnitude. And I will leave that to you and move on. And in this case, it means finding parametric equations for the tangent line to a curve at a given point. The curve is given by x equals t squared plus 1, y equals 4 times the square root of t, and z equals e to the t squared minus t. Like t squared minus t is the exponent. The point is 2, 4, 1. Before we do our work, let's talk a little bit about what a tangent line is in this context. For a curve C, given by r of t, the tangent line to C at a point P is the line through P that is parallel to the tangent vector. Remember that the things that we need in order to come up with the equation of a line are a point and a direction. The point is given by 2, 4, 1. The direction is going to be given by r prime of t. And even though we were given the curve in parametric form, we can write it as a vector. R of t is equal to t squared plus 1, 4 times the square root of t, e to the t squared minus t. If that is our vector, then our derivative, r prime of t vector, is 2t, 2 over the square root of t, using the power rule there for the square root, and 2t minus 1, that quantity, times e to the t squared minus t, using the chain rule and the derivative rule for exponential functions. We have the point 2, 4, 1, and that'll be good for our symmetric, are we going for or parametric equations, excuse me, for the tangent line, but that doesn't help us figure out r prime of t. We need a value of t. We can look and see if x is t squared plus 1 and x is equal to 2, then t must be equal to plus or minus 1. If y is equal to 4 times the square root of t, and for our point y is equal to 4, then it follows that t must be equal to 1. So we've nailed it, but let's go ahead and confirm using the using z in the k component. Z is e to the t squared minus t, and that's supposed to be equal to 1 from our point. And therefore we see that, yeah, we confirm that t is equal to 1. Okay, so our tangent vector at the point where t equals 1 is r prime of 1, and since r prime has components 2t, 2 over the square root of t, and the quantity of 2t minus 1 times e to the t squared minus t, our tangent vector is going to be 2, 2, and then it looks like 1. That gives us our direction for our line. As for the point was given to us as 2, 4, 1. I do remember now we were asked for parametric equations. So x, y, and z are going to start out with the point 2, 4, 1. And then we're going to add using the direction vector. That gives us our coefficients 2t, 2t, and t, where the coefficients there come from the direction vector. So x is equal to 2 plus 2t, y is equal to 4 plus 2t, and z is equal to 1 plus t.